This is the study of geography, and these are the branches of geography: physical geography, human geography, and practical geography. These are among the few topics that we look at when we study geography. We look at industrialization, we look at forestry, we look at tea plantations, maize plantations, brick making industry, among many others. Welcome to this YouTube channel, and I hope you pressed the subscribe button at your right side down here so that you can get notifications of more lessons. We are on to our second lesson, Geography Form 2, Causes of Earth Movements. Welcome to this lesson. Learn with us.
I hope you are fine. You are welcome to the work that we have today. We are going to look into the topic that we had already started, and this is about the movement of the earth. We have two types of earth movements. We have the rotation of the earth, and as well as we have the revolution of the earth. Now, we had said that the rotation of the earth is the spinning of the earth on its own axis once in 24 hours. And we also defined the term revolution, and we said it means the movement of the earth on its own orbit around the sun once in a year. Now today we're going to look into the effects of the revolution of the earth. We had said that the earth is tilted when it is rotating. It is tilted at 23.5 degrees northeast, and when it is revolving, it is tilted at 66 degrees. You see, it is bent, maybe that's what we should say. And this tilting is calculated. That's what we may also say. That the tilting of 23.5 degrees and that of 66 degrees is calculated. It is very important in the sense that as the earth is moving round, as the earth is moving around the sun, some part of the earth is bent towards the sun. Maybe the northern part, that is the North Pole, or the South Pole, at one time of its journey, one part of it is facing the sun and another one is directly facing away from the sun. As one part of the earth is facing the sun, that one has got a very great impact on that environment. And even as it is facing away from the sun, it's having an impact. This is very different from what we had said in the rotation of the earth. We said that during the rotation of the earth, one part of the earth is facing away from the sun and another part of the earth is facing towards the sun. And this one gives rise to the day and gives rise to the night. But today we are talking about that when the northern part of the North Pole is facing the sun, the South Pole is facing away from the sun. And when the South Pole is facing the sun, the North Pole is facing away from the sun. And this is because of the tilting. We are talking about the tilting. The earth is not vertically positioned. It is tilted. Now this tilting and this revolution has got effects. And so we start with the first effect, effect number one. We are talking about the revolution of the earth causes the 4 seasons, and we need to know them. We have summer, we have autumn, we have winter, and we have spring, and they follow that order. We cannot talk about summer, winter, we can't mix like that. We talk about summer, and then we talk about autumn, and then we talk about winter, and we talk about spring. They follow each other. Summer is very hot. Autumn is cold. Winter is cold. And spring is again the improvement of the temperatures from being cold towards being summer. Now, now when we are talking about summer and winter, you know, this is not very practical on the land on which we live. We are on the equator. We lie on the equator, maybe some 2 degrees or 2 degrees south, 2 degrees north. Some of us, you know, like 1 degree on south of the equator, you see, up to 5 degrees, that is where Kenya is. So, in other words, the sun is always overhead our land. But when we talk about places which are very far away from the equator, and always when we are numbering these places, we number the latitudes from the equator. So the equator is the lowest point, and the North Pole and the South Pole is the highest points that we have. Now, so the equator is a low latitude. The land on the equator is on low latitudes. And the land on the poles is the high latitudes. Now, the low latitudes, they have the sun overhead throughout the year. The high latitudes have sometimes the sun being overhead them, and sometimes the sun is very far away. So when the sun is in the north, when the North Pole is facing the sun, that is in June, around June, when the sun is in the Tropic of Cancer, around the time of June, the high latitudes in the northern part or in the northern hemisphere, high latitudes in the northern hemisphere, they experience summer. At the same time, in the south, high latitudes in the south, the sun is very far away from them and they are experiencing winter. Now, in December, the sun is in the south. The South Pole is facing the sun. And therefore, at that time, high latitudes in the south, they are experiencing summer, and high latitudes in the north, they are experiencing winter. Now, if we were in the north, and we are saying that in June, the sun is directly above the Tropic of Cancer. And at that time, all regions north of, around the Tropic of Cancer and north of the Tropic of Cancer, they are experiencing summer. Then the sun is now starts moving towards the equator slowly. Every day it is approaching the equator, such that by September we shall have the sun directly above the equator. And therefore, as the sun is approaching the equator up to September now, that time it is autumn in the north. Then the sun continues its journey towards the South Pole. And therefore the north gets very far away from the sun, it's facing away from the sun, and therefore it experiences winter. The north, in June, they are experiencing summer. In September, when the sun is directly above the equator, the north is experiencing autumn. In December, when the sun is directly above the Tropic of Capricorn, the northern part, high latitudes in the North Pole, are experiencing winter. And in March, the sun is now directly above the equator again. The north, they will be experiencing spring. And as again the circle starts over again, that the sun will again move to the north, and it will be summer in June. The south also has got its circle, that in December, the sun is directly above the Tropic of Capricorn. And at that time, the southern part, in the southern hemisphere, high latitudes in the southern part, they are experiencing summer. Then, In December, the sun is directly above the equator. So the sun is moving northwards, and it is autumn in high latitudes in the south. Then in June, when the sun is directly above the Tropic of Cancer, 23.5 degrees north of the equator, in the south it is winter. In March, the sun is directly above the equator, and that is autumn in the south. In June, when the sun is directly in the Tropic of Cancer, 23.5 degrees in the north, the south is very far and it is facing away from the sun, and that is winter in the south. In September, the sun is again on the equator and it is now on its way to the south, and it is spring in the south. So the North Pole and the South Pole, high latitudes in the North Pole and the high latitudes in the South Pole, they experience all the 4 seasons, and they are very clear: summer, autumn, winter, spring. So they experience that, and that is an effect. Now we also have another effect, effect number 2. It causes a variation of the length of the days and nights at different points on the Earth's surface at different times of the year. I have said that revolution causes a variation of the length of the day and the length of the night at different places at different times of the year. Yes, this point is also not very clear to us, because always here on the equator we have 12 hours, we have 12 hours day, we have 12 hours night. But that one is not the case in the high latitudes. It is not the case in the North Pole and in the South Pole. Places which are very far away from the equator, they sometimes have very long nights, sometimes they have very long days. That is the time when the sun is appearing. What we could call morning and evening here on the equator means that them, it can be very long. Sometimes they have one long night, 24 hours. Yes, when the sun is directly above the Tropic of Cancer, when the sun is directly above the Tropic of Cancer in the north, all places that are north of the Arctic Circle towards the North Pole, 66.5 degrees north of the equator, they receive sunlight on that particular day, 21st June. They receive sunlight for 24 hours. So that is a long day. It is a long day. At the same time, all places south of the Antarctic, 66.5 degrees south of the equator, that place now is facing away from the equator, and it is experiencing one long night of 24 hours on 21st June. Now, what happens when the sun moves from the north? We said in June it is in the north, in September it is on the equator, in December it is directly above the Tropic of Capricorn in the south, 23.5 degrees south of the equator. At that time it is summer in the south, yes. But on that day, 22nd December, when the sun is directly above the Tropic of Capricorn, all places south of the Antarctic, they experience total sunlight for 24 hours. They don't have a single minute for darkness. At the same time, all places north of the Arctic Circle, they receive darkness for 24 hours. So we are right to say that this revolution, because the earth is so much tilted like the way we said, this revolution will make one place to receive total light for 24 hours, another place to receive total darkness at that time. And as the position changes, the other place also comes to experience what it was not experiencing at that time. So it is a reverse. And we are saying that this is not so sudden that you will say that it will wait for 21st June for it to have 23 hours, 24 hours daytime in north, and at the same time 24 hours darkness in the South Pole. No, it is progressive. It is progressive, such that on the day before, it was around 23 hours and some minutes total day, and a few minutes for sunlight in the north. You see, even in the south, it was 23 hours darkness. You see, so as the sun is approaching the north, the length of the days increases as the length of the nights becomes smaller. The hours, they reduce. And as the sun is moving to the south, the length of the day hours increases as the length of the night hours decreases. So that is what is happening, and that is an effect of the revolution of the earth. Beautiful. So we have looked at two effects. It causes the 4 seasons. It has also caused a variation of the length of the days and the length of the night hours. The day hours and the night hours, they are not uniform over the earth surface. Some places right now, like this is, we are approaching June. The sun is so much in the north. So the length hours of the day, they are experiencing maybe 17 hours. Some places they are experiencing 19 hours, because we are approaching towards June, when they are going to have total light for 24 hours. The third effect is that the revolution of the earth causes changes in the altitude of the midday sun. How does this happen? We have already said that this revolution causes a difference in seasons. At one time, there is summer in the north. At another time, there is summer in the south, or winter in the north, winter in the south, different times. Now, when we have summer in the north, we have this date, very special date. And on this date, we have, on 21st June, the sun is directly overhead the Tropic of Cancer. 21st June. At this time at noon, the sun is at 90 degrees at the Tropic of Cancer, 23.5 degrees north. On September 23rd at noon, the sun is directly above the equator, 90 degrees at the equator. So if we are on the equator and you stand at noon time, your shadow will be between your feet. Your shadow will be between your feet. It will be the shortest. Now the sun will continue moving to the south, and we are going, the apparent movement of the sun, the sun approaches the south, and in 22nd December, the sun is directly above the Tropic of Capricorn. On that date, at noon, the sun is at 90 degrees. So that is the variation in the altitude of the midday sun, the noon sun. And in March, 21st March, the sun is directly above the equator. At noon, it is 90 degrees directly above the equator. So that is what we mean by this point, that it causes changes in the altitude of the midday sun at different parts of the earth at different times of the year. 22nd December, it is directly above the Tropic of Capricorn, and in 21st March, it is directly above the equator. Now, we have what we call the phenomena that are caused by this position of the sun. That in 21st March, we have already noted that the sun is directly above the equator on its way to the north. And on 23rd September, the sun is directly above the equator on its way to the south. On this date, the number of hours are equal for the day and for the night. 12 night hours, 12 night hours. On these two dates, 21st March, 23rd September. And this is a phenomena which we call equinox. An equinox is a phenomena during which time the sun is directly above the equator and the number of hours are equal between the night and the day for all the parts on the Earth's surface. We also have another phenomena that we call the summer solstice. The summer solstice is experienced on 21st June when the sun is directly above the Tropic of Cancer in the north. On this date, all parts north of the Arctic Circle, 66.5 degrees north of the equator, they experience total sunlight for 24 hours. They don't register a single minute for darkness. And this is what they term the summer solstice. The northern pole or the region north of the Arctic center is tilted towards the sun, and therefore it is one long day. That is a summer solstice. In 22nd December, the sun is far in the south. The sun is directly above the Tropic of Capricorn. On this date, it is summer in the south, but it is winter in the north. All the region north of the Arctic Circle, 66.5 degrees north of the equator, they don't see the sun. It is total night. It is total darkness for 24 hours, and that is what we call the winter solstice. So we have three types of phenomena. We have the equinox on 21st September. We have the equinox on 21st March and 23rd September when the sun is overhead the equator. We have the summer solstice on 21st June when the sun is overhead the Tropic of Cancer. And we have winter solstice in 22nd December when the sun is far in the south and all regions north of the Arctic Circle, they don't receive any light at all. And then finally, we have the fourth effect of the revolution of the Earth, what we call the lunar eclipse. Revolution of the Earth causes the lunar eclipse. The lunar eclipse is a phenomenon in which the sun, the moon, and the Earth, they lie on a straight line. And the Earth lies between the sun and the moon. And when it lies between the sun and the moon, it blocks the sun rays from reaching the moon, therefore causing a shadow, casting its shadow on the moon. This is one of the proofs that we said that the Earth is spherical, because the shadow of the Earth is casted on the moon, because the Earth has blocked the sun rays from reaching the moon. Now, this one happens because when the Earth is moving around the sun, at one time it finds itself being right in between the sun and the moon. And we have an illustration here, and this is what we call the lunar eclipse. This is what we call the lunar eclipse. We have said the sun, the Earth, and the moon, they lie on a straight line. The sun is the largest. We had looked at this. The Earth is very large, and the moon is much smaller, and they lie on the same line. And the Earth blocks the sun rays from reaching the moon. And at the center, it is heaviest. The center is darkest, and this is what we call the umbra. and the part that is on the outside receives some partial light, and it is what we call the penumbra. And this is what we refer to as the lunar eclipse. It is caused by the revolution of the earth around the sun. We also have another type of eclipse that we call the solar eclipse. In this case, the moon lies between the sun and the earth, and it is caused by the revolution of the moon around the earth. And we don't dwell on that because ours is the study of the earth as the home of man. And therefore, that is what we have as an effect. So those are the main effects that we have had of the revolution of the earth around the sun.
Continue watching this YouTube channel where you will get more similar content to help you during your study in high school, and kindly share so that your friends can get the same kind of content and be helped in their study as well. Thank you. Have a nice time.